Hi, welcome back. In this video, we're going to talk about special angles in Quadrant 1, specifically the sine and cosine values for these special angles. So in a previous video, I established where we have these two reference triangles, and I explained where they came from, but here I'm just going to give you the triangles and we'll move from there. So we have two triangles. The first is a 45-45-90 triangle. We use that language to represent the degrees of the angles. And this triangle has side lengths square root 2 over 2, square root 2 over 2, and 1. So what's important here is the ratios of the sides. So you may see some other texts or other teachers talk about a similar triangle, and it is actually similar in the mathematical definition, where the side lengths would be square root of 2, square root of 2, and 2. So we would multiply everything by 2. This would work just the same. I just focus on this one because it has that radius of 1 that reminds me I'm typically talking about the unit circle. So just a comment in case you're seeing that other places and wondering why this one looks different. So this is our reference triangle for angles that are related to 45 degrees. And we also have a reference triangle that is the 30-60-90 triangle. And this one will be used for 30-degree and 60-degree angles and those related to them. So this triangle has the 1/2 length across from the 30 degrees and the square root of 3 over 2 across from the 60 degrees, with the hypotenuse being 1. Again, you might see this triangle written as a similar triangle where everything is multiplied by 2. So the hypotenuse would be 2, the length across from 30 degrees would be 1, and the length across from 60 degrees would be square root of 3. It's really up to preference which one you use, and it doesn't matter because we're always using the ratios of sides, so we can look at similar triangles. Okay, so we have these two reference triangles, and we are going to use these to help us find the sine and cosine values of our special angles. So given this goal, let's look at our unit circle and the special angles in question here. So we're starting with this first quadrant, and then we will use symmetry to talk about the other quadrants in another video. So for now, let's just look at these points and recall a couple of things. So points on the unit circle, where the radius is 1, all have the form cosine of theta, sine of theta. So the x value is cosine, and the y value is sine. This is because of the way cosine and sine are defined. This is how we chose them to be defined. We say that cosine is x over r, or adjacent over hypotenuse or radius. But here, because we are on the unit circle, we have a radius of 1, and so this is really just x. It's really just the adjacent side. Similarly for sine, sine is y over r, that's how we define it, which would be opposite over hypotenuse. And again, the hypotenuse is 1, so sine is actually just y, the opposite side. Now, we're going to use this information with our reference triangles to fill in the x and y coordinates for all of these points. So let's refer to our triangles here, and we're going to start with 45 degrees. That's our middle point between 0 and 90 degrees, or pi over 4. So if we're looking at cosine of 45, I can use this triangle. So cosine of 45 degrees, or the cosine of pi over 4, if we want to use radians, is equal to the adjacent side, square root of 2 over 2, over 1. So adjacent over hypotenuse. But when we divide by 1, nothing really happens. Something divided by 1 is just itself, and so we can say that the cosine is square root of 2 over 2. Then for sine, we would say that sine of 45 degrees, or sine of pi over 4 in radians, is the opposite over the hypotenuse. So square root of 2 over 2, all over 1. Whenever we divide by 1, it stays the same. We're taking something and dividing it into one piece, so nothing changes. And so the sine is square root of 2 over 2. So the cosine and the sine are the same for 45 degrees. And given that information, we can fill in the point on our graph. Remember, the cosine is the x, so that's our square root of 2 over 2, and the sine is the y. That's also square root of 2 over 2. So let's repeat this process for the 30-degree angle. We'll start with the 30 degrees since it's in the position that makes sense right now. So if we're talking about cosine of 30 degrees, that's the same as cosine of pi over 6, and we would do adjacent over hypotenuse. So the adjacent side to 30 degrees is square root of 3 over 2, and the hypotenuse or the radius is 1. Again, we're dividing by 1, we're going to get rid of that, so we get square root of 3 over 2 is our cosine value. Similarly, for the sine, we're going to do opposite over hypotenuse. So the opposite side from the angle, you can imagine standing at the 30 degrees and looking across the triangle, is 1/2. So we have 1/2 over 1, the hypotenuse. Again, that is just 1/2. And so we would say the sine of 30 degrees, or the sine of pi over 6, is 1/2. Okay, we're making good progress. So now we can label this on our graph. So the cosine value is the square root of 3 over 2, that's the x, and the sine value is 1/2, that's the y. Okay, so now we're going to use this same triangle to find the values for 60 degrees. So instead of starting at the 30-degree angle, we're going to position ourselves at the 60-degree angle. So cosine of 60 degrees is the same as cosine of pi over 3, and we're looking at the adjacent side over the hypotenuse. So here, the adjacent side is 1/2, and then we're dividing by 1, the hypotenuse, and so we're getting 1/2 as the cosine. We follow a similar process for sine. So we look across the triangle from the 60 degrees, and we get square root of 3 over 2 as the opposite side, and then we divide by 1 the hypotenuse. So square root of 3 over 2 is our sine value. So if we label these on our graph, we have 1/2 for the cosine or the x value, and square root of 3 over 2 for the y or the sine value. So just to really unpack this for a moment, what these points are saying is that if we go over by the x amount or the cosine, and then up by the y amount or the sine, we should be getting to this point. So square root of 2 over 2, for example, doesn't mean a whole lot, but you could type it in your calculator and get a decimal for it. So when we do that, we get about 0.71. So we're going over 0.71 and then up 0.71, and we're getting to that point on the circle. It's exactly square root of 2 over 2, so we usually use that instead. Then the same thing follows for the other points. So we would be going over square root of 3 over 2 and up 1/2 for 30 degrees, and the opposite for 60 degrees. So using this same logic, we're going to fill in the other 2 points for 0 degrees and 90 degrees. So for 0 degrees, I see that my point goes over by 1 and up by 0. So the x value is 1 and the y value is 0. This tells me that cosine of 0 degrees is 1 and sine of 0 degrees is 0. So there we go, the x is the cosine and the y is the sine. Now for 90 degrees, or pi over 2, my point is over 0 and up 1. So I'm at 0, 1, meaning 0 is the cosine of 90 degrees, and 1 is the sine of 90 degrees. So we'll be reinforcing these relationships a lot, and I know I'm being a little repetitive here, but I just really want to start it getting the pattern in your brain that cosine is the x, sine is the y, and we're going to use this unit circle with these special angles to help us get used to some of these ideas. Okay, that is it for this video. Thanks so much for watching, and I will talk to you in the next one.